Hello, Algebra 2 students. This is your midterm exam review. Your midterm exam will cover everything in units 1 through 5, so in addition to completing this review, it could be wise to print out your reviews for units 1 through 5 and work through those again. Everything should still be posted on Blackboard. We're going to start with absolute value equations and inequalities. Remember that the first step in solving an absolute value equation is to get the absolute value part by itself. So we're going to add 6 to both sides here. So I have the absolute value of 2x minus 7 equals 11. So the part inside the absolute value could be 11 or it could be negative 11 because we know the absolute value of negative 11 also equals 11. So you're going to write two equations. 2x minus 7 equals 11. 2x minus 7 equals negative 11. Add 7 to both sides to get 2x equals 18 and divide by 2 to get x equals 9. Over here you'll add 7 to both sides to get 2x equals negative 4 and divide by 2 to get x equals negative 2. So your solutions are negative 2 and 9. Okay, in the second problem, the absolute value is already isolated, but this one's an inequality. This is a less than, and so remember less than makes an and, less than. So it's going to be both less than 1 and greater than negative 1. And if it's an and statement, it's going to be between these two values on the number line after we've done the subtracting and multiplying. So let's subtract 4, and you subtract it here as well and here as well. These will cancel, and so I have negative 5 is less than half of x, which is less than 1 minus 4 is negative 3. And next, to get rid of the 1/2, we can multiply by 2, or you could divide by 1/2, whichever one you prefer. So if I multiply everything times 2, 1/2 times 2 will cancel out, giving you 1x. This gives me negative 10, and then this gives me negative 6. And usually you express the solutions to an inequality on a number line as well. So on your number line, you just need to make sure you have the numbers between negative 10 and let's see, 9, 8, 7, and negative 6. And then an open dot indicates that we're not including the negative 10 because it doesn't say equal to. Open dot here as well. And then all of the numbers between negative 10 and negative 6, not including those numbers. In problem 3, we have another inequality. This time we need to get rid of the 2 before we can start, and this is a great or symbol, which means it's going to be greater or less than, but not both. So divide by 2 first, and we have the absolute value of 3x minus 5 is greater than or equal to 10. So 3x minus 5 could be greater than or equal to 10, or 3x minus 5 could be less than or equal to negative 10. So to solve this, I'm going to add 5. And I have 3x is less than or equal to negative 5, and divide by 3. So x is less than or equal to negative 5/3, which is about negative 1.67. Over here I'm going to add 5. 3x is greater than or equal to 15, and when I divide by 3 I get x is greater than or equal to 5. So I need both of these numbers on my number line. I'll put 0 here. 1, 2, 3, 4, 5. 1, 2. So this is about negative 1.67, which will be between negative 1 and negative 2. and it's an or equal to, so I need to include the number. So I'm including negative 1.67, I'm including 5, and I want less than or equal to negative 1.67 or greater than or equal to 5. And somehow I need to have these two answers together in my solution set, so I'm going to write them in a solution set. Let's see, I'll write it right here. And then put a box around it. Okay, in number 4, we have the function f of x equals negative 3x squared minus 4x minus 5. To find f of negative 1/2, you need to put negative 1/2 for all of the x's. So f of negative 1/2 is equal to negative 3 times the square of negative 1/2. Remember to put it in parentheses with a squared outside, minus 4 times negative 1/2 minus 5. And the easiest way to evaluate that is to pull out your calculator. Okay, so let's clear what we have here. And let's type 3 times negative 1/2. Close your parentheses, squared, minus 4 times negative 1/2 and minus 5. So we get negative 2.25, and if you want that in fraction form, you can press math, fraction, and we get negative 9/4. Okay, next we have some variation problems. In number 5, y varies jointly. So varies jointly is like direct variation. Direct variation is y equals kx. Joint variation is often y equals kxz, but in this case it's z that varies jointly, so we start with a z. So z varies jointly. You need the k, which is the constant, and it varies jointly with x and y. So we need to find the constant of proportionality. The constant of proportionality is the k. So we're going to plug the numbers in and solve for k. 21 is your z. We don't know k. We know x is 1/2 and y is 3. So you can multiply 1/2 times 3 and get 1.5. So 21 equals 1.5 times k, and then divide by 1.5. And if you type that in your calculator, you should get k equals 14. Okay, in problem 6, we're trying to find the vertex of the graph. You can tell by the squared here that this is a graph of a parabola. And the parabola's vertex starts at 0, 0. But it's going to be shifted. So because of the x plus 5, we know that it's shifted left 5. And because of the minus 3, it's shifted down 3. So if you go left 5 and down 3, your coordinates are negative 5, negative 3. You can use the same idea in problem 7 because this is an absolute value that has been transformed as well. So x minus 3 is going to move the vertex of your absolute value right 3, and then plus 5 is going to move it up 5. So there's your vertex. And normally your graph would go down 1 and over 1, down 1 and over 1 on each side because of the negative. But in this case, it's going to be stretched by 2, so it's going to go down 2 and over 1, down 2 and over 1 on each side. Now this is an inequality. It says y is greater than or equal to. So because it says or equal to, you're going to use solid lines. And because it's an absolute value, this is why I made the straight line. So the absolute value makes the V shape. If it's greater than, the numbers that are greater than this graph are above it. So you need to shade everything above your graph. Okay, and that should be done. All right, problem 8. This is another inequality, but this time it has a squared, so it's going to make a parabola. The negative tells you your parabola is going to be upside down, but this one is not in vertex form. So we're going to find the vertex with negative b over 2a. So negative b is negative 4, and that's over 2 times a. A is negative 1. So I have negative 4 over negative 2, which is 2. So the x-coordinate of my vertex is 2, and that means the axis of symmetry is at x equals 2. Then you can plug that 2 back in here to find the y-coordinate. So it'd be negative 2 squared plus 4 times 2 plus 5. 2 squared is 4, and then stick a negative on that. You've got negative 4 plus 8. So I have negative 4 plus 8 plus 5 is going to give me 9. So my vertex is at 2, 9. So I'm going to go to 2, 9, and make my vertex. Now the parabola shape, the parent graph, is normally going to be over 1 and up 1, over 2 and up 4, over 1 and up 1, over 2 and up 4. Now there's no stretch on our graph, but it is flipped, so that our graph is going to go over 1, down 1, over 2, down 4. I think I didn't do enough there. Let's fix that. Okay. And it does not have an or equal to on it, so it's going to be dashed. Dashed. Now y is less than this graph, so the numbers that are less than the graph are below it. So we're going to shade below the graph. Now you can check either of these graphs on your calculator. Let's check 7 first. So for 7, I'm just going to check the shape. I feel confident that if y is greater than, it's going to be above. But I do want to check and make sure I got the right shape. So let's clear out what I have in here, and I'm going to type negative 2. Remember, to get absolute value, you need to go to the math button and go over to num, and it's that first choice, ABS. So negative 2 times the absolute value of x minus 3. I have this ABS with parentheses on mine. Yours might actually look like the absolute value that is in the problem. And then I have plus 5. All right, so if I graph that, it seems to confirm what we did by hand over here. So that's a good check. All right, and let's check the other one over here too. So go back to my y equals and clear it out. I'm just going to check the shape. So y equals negative x squared plus 4x plus 5. And hit graph. And we're hoping to see that we have the shape that we expected to see, and we do. Notice I drew my axis of symmetry at x equals 2, and if you go to x equals 2, you can see the axis of symmetry there. If you wanted specific points to plot, you could hit second graph, and that will give you a table of values. So I have 0, 5, 0, 5 is over here. I have 1, 8. I have 2, 9. These are the points I could graph. Remember that if you need points that are negative, you can go backwards. If you need further positive points, you can go forwards on this. Okay, so I'm going to stop this video, and we're going to pick up with a second video on page 2.